little bit different because this was a real-world troubleshooting where I went, oh my gosh, something's bad with my computer, right? Malware, how did it get there? What the hell happened? Initially I was like, I got this. I do packet analysis. I'll be done with this in 5-10 minutes. Turns out it was just a rat hole that I went down on things that I thought I knew how to do. So I thought I would share that with you. And also some of the tools that I tried along the way that I was very familiar with. So I'll show you how I did it, what I had to go through, and the conclusion that I came to. The one thing, the template of SharkFest said, ruling the world through packet analysis or looking at packets, and it's not. When you open it, I'm sure you all had that feeling of what the hell am I looking at? You can only learn this by doing packet capture. So if you don't packet capture for fun, chances are you'll never learn enough, right? Because it's through repetition that you get good at it. And packet capture is one of those things. The guy that wrote that book, Blink, very, very good book, he said 10,000 hours is what separates a world-class athlete or anybody. So if you love your craft, if you like packet capture, after you look at it for 10,000 hours, you get good at it. And I'm talking world class, right? So wherever you are, do packet capture and study. Airplanes, great place to learn on how bad networks impact applications, right? It's like a study case of how to high latency, and most of us don't, unless you're in the military, you don't experience 500 millisecond round-trip latencies, okay, and what it can do to TCP and how it breaks things, unless you're on an airplane. And that's, so you get serialization delay, you get high latency, it's a great way to learn. And I said here formerly Riverbed because I was with Riverbed for about 7 years, and as of earlier this year, I'm not. So from an information perspective, you don't have to write any of this down. This will be available. And you saw the VR flight sim, obviously not on the recording, but I showed you the DCS flight simulation. Woodworking is my another passion. I think I do it because I like to collect tools maybe, but I like power tools, I like woodworking, because everything I do is so, I built giant networks, I'll talk about that in a second, but I never really touch anything. I never really build anything with my hands, and I'm a kind of a handyman kind of guy, so woodworking is a great source of creating something with your hand. It's fun. And of course, a lot of packet analysis, that's what the video YouTube channel is about. All of the content, recording, the packet capture, it will all be available in this box link. And again, you can see this in the retrospective, so you don't have to copy these links down, but if you just Google box.com and SharkFest, you'll find these things. Twitter, I tend to not stay on Twitter too much. Maybe once a week, I just quick things in and out, and then my contact information. So who am I and why are you here, and what gives me the right to give this lesson? And I changed this as Gerald was talking, and I titled it, "Kids, Get Off My Lawn," because I feel pretty old. I think I chuckled when Peter said, back in 2011, he got started. And I was like, 2011? Like, wow. So that first line I added, when Peter said that, because when I started, C was like this new thing, not worthy of a semester of computer science. So they lumped it with 3 other languages, because it was the very first time it came out. Okay, so it kind of gives you the idea of timeline. And there's a reason why I say these things. Again, that 10,000 hours, it started back then, right? And Turbo Pascal, you heard Gerald mention it. I didn't have Turbo Pascal. I didn't have an IDE. And I remember the one program I was working on, what's called off by one error. So if you do computer engineering writing program, you know about off by one, whether you post increment and pre-increment. And I had a bug and I couldn't figure it out. So I sat through and ran through my code on paper, jotting down the variable, I'm at 101, I'm at 102, 103, and then I was like, there's my bug. And then someone said, dude, you should try Turbo C. I was like, what's that? Very expensive for a student at the time. I got it, and then you could set a breakout, and I was like, oh my God, this is better than, best thing since sliced bread. So, and then the other one is the Morris Worm. I was on a VAX. Again, I changed all of this while Gerald was talking. It was a VAX VMS editor. I logged in, and the message today was, hey, if you noticed the slowdown yesterday, please contact the field office of FBI in Arizona. And I was like, what the hell is this about? And that was when the Morris worm was first released inadvertently, and it spread throughout, right? So, and then after many, many years in the Army and doing this and that, I ended up in Citigroup. And that's how I got started with packet analysis. Actually, it was before that, but doing it full-time was designing a large network. We had some BGP issues, OSPF issues, and there are certain BGP conditions that you cannot solve with just show commands because you need to see what's in the packet. There are frame relay stuff that you can only solve by looking at the frame relay control packets that no show command will show you. And I was a sniffer bigot, a DOS one at that, because to be fair, when Sniffer converted to Windows, they just bought this another package, bolted it on, it was utterly useless, got in my way. And what I liked about Sniffer was that the tool got out of my way of troubleshooting, because I have muscle memory on how to troubleshoot, and I don't like tools that get in my way. And at first I was like, Sniffer. And then Kristen, who worked for me, she said, hey, you tried this thing Ethereal? And I was like, yeah, I tried it, but it's like, got Sniffer. And I had the luxury of having 40, 50 sniffers that I had access to. And then every day I would see her do something and I would go, hey, how'd you do that? How'd you do that? How'd you do that? And I realized that Sniffer's time had come. And then I contacted Gerald for commercial support, so it was still packet analysis, protocol analysis, but Ethereal was much more efficient and more robust than Sniffer. Never looked back. I already talked about it being so. And what do? I sell computers for a living. So Gerald mentioned that. My dad, every day he calls me and he says, so you're selling computers all right? You doing okay with selling computers? And I'm like, yeah, Dad, I'm killing it selling computers. One advice I would have for you is that for your immediate neighbors, don't talk about computers, because then you become tech support, and they'll call you with every computer problem and Wi-Fi and Linksys and whatnot. So for people afar, you can say you sell computers or do computers, but for your immediate neighbors, just tell them you do something boring, so they won't call you. The bus factor. So I do have a story. So I mentioned before the session started that I wanted to spend some time talking about what you guys do, some experience. So I'll share a bus factor for you. Again, I typed this when Gerald mentioned the bus factor. So 2 days after September 11th, I live in New York. I work for a large bank, Citigroup. And we had a major outage, obviously. Major doesn't do justice, but there was a problem where ATMs going down and people needed access to money. In New York it was more horrific than, because we were ground zero. And I said, I bet you that telco never disconnected the circuit that we disconnected. And I said, if I have access to that circuit, physical handoff, I'll just redo the routing on the fly and get this stuff up and running. And they said, you know what, I think you got something there. So I went to Manhattan, got a police escort downtown to Wall Street, 111 Wall Street, and no one was allowed down there, so the police had to take me there. And but I don't know the data center. I do everything through terminal servers. I don't know where these physical routers are. I mean, it sounds stupid, but these are massive data centers. So it's not like I'm going to go there and find this router that I need to put console into and change. These are things that you don't think about until you're like, oh crap, there's, it's a huge, huge data center. So I had one of the data center guys meet me there. And he was a little late, and he shows up, and his jeans are torn, t-shirt's torn, he's bloodied a little bit, and I said, let's just call him Ed. Ed, what the hell happened? And he looks at me a little bit shocked, and he goes, I got hit by a bus. I went, what? Because he was rushing to help, he actually got hit by a bus. And I said, Ed, what the hell, man? Go to the hospital. And he said, no, we got to get this up and running. I said, I love you, Ed, but you got hit by a bus. You could be bleeding out internally. For God's sake, please go to the hospital. And he's like, you think? I was like, yeah, I think. I said, but before you go, show me where the hell this router is. because I would never find it. And then he showed me the elevation diagram and where it was, and sure enough, when we pulled the HISI cable at the time, and we overrode the password of last resort, which is like 40 characters, and it was a whole thing. We got the thing up and running, right? So that's the buzz factor story. So I want to hear some of these types of stories, some of your experiences as we get to toward the end of the session, okay? All right, with that out of the way, let's get to troubleshooting. I had a problem. I had a big problem, I thought. And my problem was this. So instead of opening up event log, I was doing some just quick checks, and I opened up the event log, and I saw this. So let me zoom in a little bit. You see that warning, DNS? It goes back a little bit further than this, September 11th. Wow. Oh, I didn't even, like, totally coincidental. September 11th, DNS client error. I was scrolling through because, you know, this is all related. My DCS flight simulator was slow, acting up, and I thought, what the hell's going on? And I was going through and looking at this, and that caught my eye. And then, look at the URL that is trying to resolve, windows-sucks.com. I thought, well, that can't be good. What's this about, right? And I thought, malware? Like, how the hell did I get malware on here? I don't have anything. And I recreated this on this laptop, which was brand new installation of Windows. This is work laptop. I don't do anything untoward on this laptop because it's a work laptop. And I thought, how the hell is this happening? And I thought, hey, no problem. You know what I know? I know how to use DNS. So I did what anybody would do. Can you read that font okay? Is it in the back? Is it? Okay, I'll zoom in after I do it. And then, of course, I went to NS lookup. And the first thing I did was set type equals SOA. Oops, sorry. Okay. Set type equals SOA. That's start of authority. So it gives you the contact information of whoever the domain is owned by. Okay, I'll give you an example. So if we do yahoo.com, you can see in the start of authority, for mail address is hostmaster.yahoo.inc.com. Now, I don't know if anybody monitors that. They're supposed to. But there's your contact information and how often it refreshes and expires. And this is how DNS replicates itself, right? Because it refreshes from down the road and the primary name server, et cetera. And so I said, I'll contact who it is and see who owns it, et cetera. And I typed that. So Windows-sucks.com. And I don't get anything because that domain name is gone. It's no longer active. And I said, oh, that's okay because I can Google and get the contact information. So I did that. I started Googling. But the problem is, it turns out, you can't Google for Windows sucks because it's all about people complaining about Windows sucks. So, and then you try to quote it, and I just, next page, and I set the record, I think, on how many pages I had to go down Google until I found articles like this. There's a corresponding website called linuxsucks.com, and there's thissucks.com and thatsucks.com. And someone mentioned back in 2001 that, you know, Microsoft fanboy, the usual vitriol that you find on, you know, internet, right? Pick any topic, doesn't matter. Somebody's pissed off about it. Any topic, I guarantee it, right? Everybody has an expert. And then I started to go down this road of windowsucks.com and this and that. And then I said, okay, fine. I'll get to the owner of windowsucks.com to at least see who owns it and whatnot, okay? But then it turns out, you know, the get off the lawn, when I was doing this back in the days, it was all open. You could get this information without any issue. Now it's not. Historical DNS record, it turns out, is owned pretty much by one company. It goes by multiple names, and if you Google it, you'll find these various companies, and it's like $99 subscription, and you can get the historical ownership of domain name registration. Okay? And I was like, what the hell? It's supposed to be free, but it's not. So I couldn't figure out. I did get down to the last ownership. I won't bore you with the gory details. With my Google foo, I found out that the last person that owned it lived in Puerto Rico, and that's as far as I got. Okay? So I still had a problem. Why am I getting windowsucks.com DNS, and who's doing it? So then I went to plan B. I couldn't do it through DNS, so I said, I will run Wireshark all day, every day, until I catch who did it, who does it, because I know Wireshark. So I did. So I set up a capture job, okay, and I said UDP port equals 53 or ICMP. And I'll get to why I do or ICMP on every capture job that I have. So I did that, and then of course I don't want to run it in live, so you can actually go to options here and say, I want you to create a file consisting of 100,000, and I want, or a certain size, or how many seconds, and it keeps writing it out. And so I ran it for days on end, because I don't know when this was happening. It didn't happen all the time, it happened sometime, and judging by the event log, it wasn't that often that it happened. Okay? And then I caught it. I found in one of the capture jobs, so if I were to, I don't want to capture it now, so if I run this now in live time, and let's just go to, I can either wait, or I can just fire up Firefox, and on the home page it's got all these different quick things, and you will see that, sure enough, all the DNS is there. And I thought, this is awesome. I'll catch these, the guy that's doing the windowsucks.com. But there's a problem. The problem is, I'll stop this. Let's just pick any one of these. Some OCSP, some Linux certificate stuff. I'll just pick one. It doesn't matter. I don't even know what this is, okay? Fine. I see the domain name querying here. The problem is, it's a socket number. I can only get as granular as a TCP port number, and I can't find or correspond that port number with the application, right? It's not enough. So I said, okay, and remember I'm doing this at 1, 2 in the morning, and I thought, that's okay. I'll go down another rat hole, because there's another tool that I'm quite familiar with back in the days, and it's, actually let me bring my icon back real quick, and that's Process Explorer. Okay, so anybody that's ever done Windows administration or done Windows for a while knows the sysinternals tool set, right? So this guy, Mark Rusevnovich, he's a PhD, had a company called sysinternals, then now works for Microsoft, has an incredible set of tools that you can use, one of which is looking at process ID of the application, whatever the application. So I said, okay, I can find the socket number, I can find the port number, I can use process ID to find it. Brilliant. Gotcha. Okay, and I go down this road. Not really. Not really. And I'll tell you why in just a second. Okay? And the problem is that even if you have this information, it's not enough. So I'll show you how. I said, okay, doing Wireshark process ID, Process Explorer is fine, kind of manual, you have to go back and you have to catch it in real time. It's a whole thing. So I downloaded Message Analyzer. This is Microsoft's free analyzer, and because it's from Microsoft, it has some usefulness. It's a good packet protocol analyzer, especially when it comes to Windows, because it has things that Wireshark, running as an application, doesn't have access to. So if I start a local trace, I can, and it's going to start capturing my Wi-Fi here in just a second. There it goes. I can actually come over here and say, you know what? I want you to add the process ID. Okay? And you can see it capturing the thing, and there it is, process ID and process name even. Okay? Beautiful. I don't even need the process ID because I can add process name as a column. And as it's making here, and I thought, this is awesome. I'm just going to wait until it makes that DNS query, and I'll know which application did it. So I let this run. Then I realized something, and you can actually see it right here. In the first couple of lines, look at the second line here. Okay, I didn't have to do anything. You can see DNS. Okay, that's 224. Got it. But here, these are all 224, 224. But the multicast part, link local stuff, doesn't matter. Just that's a DNS query, so pretend that's a unicast DNS query. If I come over to the right, look at the name of the application. Servicehost.exe. And I thought, well, that's no bueno. Because it turns out, and I Googled some more, it turns out that in the world of Windows, all DNS happens through this guy, servicehost.exe. Which means that getting the process ID isn't enough. Because I need to know who forked the call to this guy to find it. And I thought, I can do that too. So I did. So I went down the road of, and I'll open up, oh no, that's not it. Let me just open up the other one so you can see it. So it wasn't enough to have service. I needed to see who made that call. And you can see here, I found the link that shows you how to do that. Okay. And what it turns out was that you can't really do it unless you have a Windows debugger installed. Okay? So I said, okay, I can do that too. So then I went and got this Windows debugger to go into the thread itself to see who spawned it. Okay? But it didn't really work out like I thought it would work out because there's no logging. I had to sit there and watch it and then catch it, and if not, it overruns. And I couldn't find a way to log it, and that didn't work either. Okay? So, and the other tools that I used, I'll show you real quick, because initially, before I found the process ID problem, was I went to my usual go-to, some of these tools that I use, which is DNS Query. Yes, I can do UDP port 53 with Wireshark, but this is ready-made from Nursoft. I use a lot of the stuff from Nursoft because they have these boutique things that makes it easy. Just keeps DNS queries, okay? What I did with Wireshark, which was UDP port 53 or ICMP and logging it, this guy does automatically. Quicker, easier, I like it, and that didn't work either. It didn't work because I found the service host.exe problem here as well, okay? And then while I was doing this, I said, okay, I went down this road because TCP Log View, again from Nursoft, does something similar as Messenger. And that is if I go to a site, let's go to my fantasy football site that I suck at, and you can see here, process name is here, okay? And initially, this gave me hope, I'll find it, and again, no bueno, because I ran this for days on end, because you can actually log it right to a log file, and you can just grep for it, and it was beautiful, I thought, and then I realized the namesake TCP log should have been my first clue, but I thought TCP was generic. Like people say TCP IP, even when they're talking about UDP, right? And then so I wasted a couple of days. I was like, how come there's no DNS lookup here? I was like, damn it. It was literal. TCP log meant TCP only. Scratch that. And after this, I went down the Process Explorer, followed by this and that, etc. Okay? So that didn't work out either. And then I Googled some more. And it turns out that if you, Here it is. Because what I did was I Googled the servicehost.exe and DNS, and sure enough, it turns out that if I stop a service, namely this DNS service client, I'm okay. It doesn't shield the DNS call through servicehost.exe. Exactly what I need. I need to know which application is making that windowsucks.com call. So I went in there. Unfortunately, everything's grayed out. I can't stop it. I'll log in as administrator. That didn't work either. Okay? And I Googled some more, and it turns out you can actually, if I go to this link, and all these links will be in my thing in case you're curious. So it saves you from hours and hours of Googling useless recommendations from people that says, oh, do this, Process Explorer. Oh, use Wireshark. Pages and pages of just use Wireshark. Just use Process Explorer, and none of it was helpful. And this link had how to stop that DNS client. And you can do it a couple different ways, through PowerShell or registry edit, okay? And if you stop this, if you change this registry and you disable it and reboot, I'm not gonna do it now, because I don't wanna reboot and record and everything, then it actually stops the DNS being called by servicehost.exe, okay? And then I let it run, and then I did Messenger and Microsoft Messenger, and let's see what that looks like. And you can see here that there's the DNS call, that's 1694, the one that's highlighted, and the DNS on the bottom, you can see towards the bottom of the screen, in the center there, windowsucks.com. And who made it? Firefox. And I thought, that's no good. Force of habit, I do Firefox for everything, and I do Chrome for work email, just G Suite. Because if you use G Suite, I just got tired of nagging. You sure you don't want to try out Chrome? You sure you don't want to try out Chrome? So I just gave in and do Chrome for G Suite for work, Firefox out of habit. I'm not endorsing one browser or another. I'm just saying I got used to Firefox, so that's just muscle memory, so that's what I do. On my phone, I use Opera. I don't know why my brain works this way, but on the phone it's Opera, on my recreational Firefox, for G Suite Chrome. It's just my OCD nature, and that's how it works. And I thought, Firefox, that's no good. Because it must be one of the add-ons that I have. And I don't have too many add-ons. And we can just go here and look at the add-ons, and they're pretty minimal. AdBlock Plus, Dashlane, that's a password encryption, mouse gestures, mute sites by default, and OneNote, and SyncMarks. SyncMarks used to be a program called Xmarks that syncs your bookmark from browser to browser to browser. Xmarks got bought by a company, then it killed it, and SyncMarks is a new one. A lot of these, I was able to download the source code. And I was able to look at the source code because I wanted to see in the source code if it's making a call to windowsucks.com. Some of these were not available, and I couldn't find it, though. Right? AdBlock Plus, I don't think I had access to source code. I might have. But some of these others, I did have source code, and I didn't. Okay? We have until 9:45, 10:45, 11 o'clock. Okay, 45 minutes. Okay, so we're on time. So I realized that it's one of these or Firefox itself that had windowsucks.com. So then I downloaded Firefox, the entire source code, like 800 meg of source code. And I have a program here, X1, that's it's a really old, when I first got it, it was really old. It's updated now. But it just indexes your email, indexes every file. It's incredibly fast. Back in the days, it started as what's called Magellan. Back in the DOS days, if you look up DasMagellan, you'll find it. This is a new And you can see how it can search everything. And if I type sucks in the file, it comes up with everything with the word sucks in it, including the source code repository. And you can see here, let me zoom in, that PDF that I showed you, linuxsucks.com, it goes through that PDF and it understands that A, the name has a sucks in it, in the content it has sucks in it. And you can see the DCS sucks, which is the next packet trace file that I'll show you. And so every one of these things here that you see has the word sucks in it. Okay? What's not in there is there's some .h file. That looks pretty, that looks good, right? It's a .h file, so I looked at them and they're not. It's not windowsucks.com. The Firefox bookmark.html was interesting. I thought, what? Firefox book? That's an exported bookmark from HTML. And if I look at it, it's got the, you can see how I exported the bookmark at one point to manually import it to other things. And if I cut and paste this entire thing, it's not there. I'll show it to you guys. So if I do the entire contents of it, there's no sucks. So I'm like, why did X1 fail me? Why is it showing me that this Firemarks bookmark.com has sucks in it when I just cut and pasted it, doesn't have it? So I said, I don't know. Let me see if I can open it with, so let me open up the folder. And there it is. And it's an HTML file, so I'll just send it to my Ultra Edit. It's an editor. Even though I just cut and pasted what X1's visualization and parsing engine showed me, there's nothing in here on sucks. So then I thought, okay, well, it's raw HTML, that's fine. I look for sucks, and lo and behold, there's windowsucks.com, ms-hidden files, sh.tml. And I thought, oh no, this is no good. Somewhere in my Firefox bookmark, hidden is windowsucks.com. How did it get there, etc. But if you look at that epic time, 152 so-and-so, if you don't know what epic time is, all of you should know what an epic time is it's number of seconds since 1970-something, I think, right, when Unix was first born. And that's the next calamity that's awaiting. So instead of Y2K, we now have, it's been long enough that the number of seconds since that relatively soon, it's going to flip over to 1970-something. So a lot of these embedded things, instead of Y2K, which was somewhat overblown, this will cause a lot of problem, my guess. But if you notice, the epic time, if I converted the epic time to human readable, yesterday. I was just testing windowsucks.com, and somewhere in Firefox bookmark, hidden unbeknownst to you, it keeps track of, I guess, sites that you've been to. I don't know. So then, late last night, I started to go down the wormhole of what is Firefox doing? Why does it do this? And then I went down the whole rat world of, Microsoft truly hides these files and bookmarks and whatnot. And then about 3 a.m., I said, okay, I got to stop. Like, I can't solve every problem in the world. Okay? But I proved that it's not Firefox source code because it would have shown up in my search of the source code. Not there. So it's one of those browsers extensions. And my next thing to do is to disable one of those at a time. It sounds easy, except windowsucks.com isn't called all the time. And there's a part of me, and I'll talk to Gerald about this, that thought maybe one of the dissectors has it, because I don't know from a timing perspective, is it when I open Wireshark to investigate that makes a call? I don't know. So the next thing I need to investigate is the entire source code for Wireshark, all the dissectors, to see when I see something and I'm like, let me see if I fire up Wireshark, because that's my usual modus operandi, right? I see something, open up Wireshark, and the timing could be, I didn't really pay attention, but it could be that when I troubleshoot, it's causing another windowsucks.com, okay? Does that make sense? So while this was not packet analysis, I just wanted to show you how I used initially DNS, command line stuff. And if you want to know more about it, you should know more about it. Get the O'Reilly book, Cricket Lou's DNS and Bind book. It's one of the industry Bibles. If you're into protocol analysis, there are some books that you must read. Cricket Lou's book, O'Reilly book, it's got Cricket obviously, his name is Cricket Lou, DNS Spine, you need to read that. It's not a hard read at all. You just read a couple of chapters and you'll know exactly how DNS works. It's more than NS lookup. You need to know what SOA does. You need to know these, how DNS propagates itself with the TTL. Because as you're troubleshooting DNS, in the US, there's a company called K Jewelry, and their tagline is, every kiss begins with K, because KAY is a jewelry company. Nice tagline, right? Every kiss begins with K. Well, guess what? Every app starts with DNS. And sometimes when you're troubleshooting slowness, it's not the application is slow, the DNS resolution can be slow. I've had this happen multiple times where people were blaming the application because as a user, you click on something and nothing happens, you get upset, you blame the network, I get called in, you troubleshoot the network, you go through the laundry list, but you have to remember it starts with DNS. Okay? And in this particular case, an Oracle application, the DNS query was incorrect. Why? Because Windows 10 and Linux default to IPv6 first. So every modern operating system makes a DNS quad A call, IPv6 name resolution first. Most of you are probably not running IPv6 at work. It times out very quickly, then goes to IPv4. Well, some application, it's a race condition, that timeout of IPv6 timing out, the application gives up and says, protocol error, network error, contact your administrator, etc. Okay? And there was a problem where no one could solve it until I looked at it, I saw the DNS, timeout, error, I put the two and two together and said, just change your Etsy. There's a number of ways to change how you do that, and that's all it took. Okay, so again, the 10,000 hours of packet analysis is all these books that you have to read, unfortunately, okay? But we're in technology, we live in dog years, right? Every year, every 7 years is a year, right, for us, because things change so often. So if you don't like reading technical books, then you're in the wrong field. Sorry, but you are, okay? And every one of you should be able to answer, what is your favorite technical book? Because if you get interviewed by me, that's the last question I'll ask you. What's your favorite technical book and why? And if you don't have a snap answer, I know you don't really read. Okay? It could be the industry Bibles, right? The Doyle book for Cisco people. If you don't know Doyle book, you don't know Cisco networking. Okay? If you don't know Craig Hunt for TCP IP administration and you're a Unix administrator, I'm like, do you really? Okay, so anyway, this is a way of judging somebody who reads either journals or articles or Radia's book, etc. These are industry Bibles that you must read. Okay? All right. So now let's get into Wireshark, another packet analysis of slowness. By the way, before we jump to it, any questions on what I showed you in terms of how to troubleshoot using all these different tools? Any questions? No? Going once? Going twice? Okay, so there's a couple other things that I wanted to show you real quick as part of this, just general troubleshooting tips that you'll find useful, and then we'll get to the next trace file, and that is using ping. So when let's open up a DOS window here. When you're troubleshooting and you want to do a packet capture with the user running an application, right? So someone says it's slow. There are certain things that happen with a SYNAC, notably window scaling factor and selective acknowledgement and a couple of negotiation, MSS, etc. It's not necessary, but useful information to have. The problem is it becomes a long trace file, and you don't know when the user did function A, function B, function C, etc. Okay? So the way to be able to do that from remotely as the user is going through it on the phone, where the user says, I did this, I did this, I did this, is to separate roughly those sections within the trace file. And the way to do that is to use -T for which is continuous, and then the -L 100. When you do -L in Windows, and Unix has a slightly different syntax, but -L means size of the packet, okay? And if you were to capture this, you would see that the ICMP packet is exactly 100 bytes, okay? So in your note, you can say, the user did a PO lookup, and then you'll start the ping, and you tell the user, let's do this. It's capturing the 100 byte ping. You say, go ahead and do that transaction. They do that transaction, I stop, and then he or she says, okay, I'm done with that. And then I immediately do this again. Okay? And so it's a good way of demarcation of that. Let's say it's a PO lookup. So whatever happened before 100 byte ping packet, not part of the transaction that he or she did. So everything in the middle here in the trace file would have it, and then this is the end of that transaction. So it's a good way of segmenting a long trace file with different functions. Okay? And then the reason why you put the -L at the end is because I'm obsessed with shortcuts, as my wife says. I look for a shortcut to my shortcut to the shortcuts. You put it at the end, so all you have to do is change it to 200. And that's your next function. And then 300, that's your next function. So it's a good way to change that. Okay? The other thing that's very useful when you're troubleshooting is, do I have it here? Is to timestamp your pings, right? And yep, there it is. So a good way to, it's not complicated at all. The only thing that you need to look at is echo time to a file. So when you use that command echo time, it just timestamps it with the time. Okay, and if you look at it, it says ping -1 that end, one ping packet, and then find the string timed out or reply. And so when you run this command, it timestamps whatever you're doing with down to the second. Okay, so as you're doing these transactions or testing, it's very helpful to timestamp everything as you're running through these testing. Okay, so that's a good way of doing that. The other one is echo dot. If you do echo dot, it sends a carriage return. Okay, so this is a good way of running a log file because you want to know at what time did this event occur. When did the ping time out? Okay, so if you're troubleshooting intermittent outage problem and you ruled out these things, maybe the network or the switch or routing is causing you grief. Now, most router people will go, oh no, if BGP, OSPF, something happens, I know about it through logging. That's fine. What if the switch port craps out on you? What if the ASIC craps out on you? What if the line card craps out on you? What if the backplane craps out on you? Okay? All of these things that are happened in my lifetime, and they don't show up in the logs. So if you run this continuous ping, you'll at least know when things go awry, because the ping will stop, and then you know at the IP level there's a problem. Okay? That makes sense? Okay, the other one that I do, you saw me do it out of habit, was when I capture anything. When you capture anything, and I did this here, I'm not going to do you notice that I have OR ICMP, okay? And you can type OR DNS in there, because when you're troubleshooting, sometimes you get focused on the target server, okay? And you're capturing everything to that target server from the end user. It's a very common thing we do. I know this user is having a problem with some server over there, right? and you're capturing either at the server end or at the client end, right? Very common thing to do. The reason why I do OR ICMP is because I don't want to accidentally miss something like this happening. And this was one of actually a SharkFest session that I did, but I'll just use it as an example. This was actually like there were a team of 24 iOS engineers, the Cisco kind. Who knew that when I say iOS, and I now have to clarify that I mean Cisco iOS, but, and it was a big problem. It's an old SharkFest session, but you see that destination unreachable? This is some random router sending a client or the server that there was a problem with MTU discovery. It's a pretty common problem. You can see the original source destination. And if you don't put OR ICMP in your capture trace file, depending on where you're capturing, you may miss it entirely because IP address is the source or the destination coming from some random router in your network. Okay? So sometimes you get focused and you go, I'll just do 2 client IP from the server, and the server sends, and you miss it because some router sends to the server, hey, ICMP packet too large, it requires fragmentation, but it's not coming from the client, it's coming from some router along the way. So it's a stupid reason to miss it, so just good practice of whatever your BPF is, parentheses, or ICMP, or DNS. That way, you don't have to worry about it. Okay? Makes sense. All right. Okay, so now let's look at, oh, by the way, one last thing. This pissed me off to no end yesterday because I was testing all this, and I thought, as I was troubleshooting this yet again and getting this session ready, I thought, oh yeah, Wayback Machine. I bet you I can find that domain name from Wayback Machine. And I was like, why didn't I think of that? Right? Wayback Machine is Internet Archive. It has all the archive. And I went there because I thought, oh man, this is perfect. I can actually find it and I'll have the aha moment. And I went to the Wayback Machine. I would look for windowsucks.com and look at that not safe for work URL at the bottom. The problem is, you see that redirecting to? It's a 302, 304, a 302 redirect. Wayback Machine website actually redirects. So instead of finding windowsucks.com page archive, it of course goes to a porn site, right? $billion business that nobody uses. You'll get that when you're on your way home. And it did. It brought up a porn site on my browser, on my work machine, and I was pissed. Like, you're an archive site. How can an archive site actively allow a redirect? It makes no sense, right? So I'll go off on a rant about that later, but as you can imagine, the stuff that came up on the browser, I was pretty pissed at that. So be careful, kids, when using the archive, because it's not so much archive anymore. I guess they monetize it this way, but I thought it was kind of a crappy thing to do. All right, any questions about that? So now let's look at some packets, shall we? And I'll give you some, so as you can tell by DCS sucks and Zippy, it's not DCS the server that sucked, because whenever I wasn't home, it was fine. So clearly it's something to do with my house. But it comes and goes, sometimes it is, sometimes it isn't, and I thought, okay, today is a day that I'm finally going to figure out why it's slow, okay? And it was wireless. The carrier provided wireless modem sucked, and because I don't have the Windows, the dongle to capture the control packets, I just narrowed it down to my wireless, a particular access point. That's why once I finally sat down and tried to rule out things, I said, oh, every time I connect to this access point, it's slow. That's why it was seemingly random. It wasn't. It was every time I did it in the living room, it was slow. So I replaced the access point and everything is fine. But that's not really the point. You can actually go to Rolf's class next he has a session on wireless, how to troubleshoot wireless, etc. So you can learn all about control plane troubleshooting there. This one, I just wanted to show you some of the tools that's available in Wireshark to look at why things are zippy and why things suck. Okay, and by the way I name things, it helps me when I go back 2 years later, 3 years later. So, so it sucks. Obviously, it sucks. So let's take a look at this packet capture, and I'll make it a little bit bigger, and I'll go through. So this profile here is when I'm troubleshooting next expected sequence of the ACK number. These are things that I went into in my other videos. So let me just go to my minimum here so we can see it with less clutter. And again, when I scroll down, right away, the things that I'm looking for are anything in the bracket, anything that's from an error perspective, and you can see as I scroll down that there was reset. Resets are okay if you're using a browser. They close out SSL sessions with reset, so it may or may not be indicative of a problem. Keep alive is no problem. There's some retransmissions here and whatnot, okay? A good way to judge, do I have a massive problem or not, okay, is this. You can go to statistics, and you can look at Stevens graph or TCP trace if you like. Stevens graph is a visual representation of. Let me pick an actual SYN packet, TCP packet first. If you go to the TCP streams graph and Stevens, you can see if I zoom out. Oops, sorry. Here, I'll do it from here. There it is. It's a very small trace file, so these individual dots represent packets, okay? And you can see a stream of packets in flight. The steeper the slope, the better it is, and we'll go into that in just a second, okay? The other way to look at it that's a little bit more useful is, I don't know why this is not being hidden anymore, is, okay, that's a little bit annoying, is this. So this is, is to go to statistics, IO graph. And when you do the IO graph, what comes up is all the packets. You can see packets per second, 12. It's obviously very, very slow, okay? But you see the bars at the bottom, and if you look at the color coding, that's TCP analysis.flags. Those are what Wireshark flagged as, something wrong. Keep alive, retransmissions, and whatnot. You can see that considering the packets per second of 12 packets per second, I don't know if those are TCP keep alives, those are retransmissions, resets. All of those qualify as a TCP analysis.flags, okay? But you can visually see, is this a massive problem or not? And clearly, in this case, I need to do a deeper dive because there's too many of those bars, the blue bar for analysis events, okay? This, if you've seen my video, I scroll down very, very fast. My eye picks it up. Why? 10,000 hours of training. I can truly pick up those brackets, and I get an order of magnitude of what's good or what's bad. But if you don't have that, this is a very good way of looking at it. So let's look at the good one. Let's look at the zippy. And we can do the same thing, scroll down, and there's less brackets. Right away, you can see there's less bracket. And the bracket that I'm talking about is any metadata. If I go down here, you can see there's one right there, right? So I'm looking for that bracket pattern, and you can train your eye to do it. Okay, and I always say this, Major League Baseball players pick up the seam for the rotation so they know whether it's a breaking ball, fastball, etc. Why? Because their livelihood depends on it, and they train their eyes to do it. You can do the same thing. Trust me, you can. It just takes practice. But again, the visual way to see that is you can look at from a Stevens graph. And you can see here now it's more steep, more dots. That means I'm getting more throughput because it's steeper. But the other one is 9:45, 10:45, 11. Okay, we're on time. Is IO graph. And you can see a couple things. Now we're talking about 1,200 packets per second, 1,100,000 packets per second. That's good. And look at the number of the bar at the bottom for TCP analysis.flags. Okay, it's very low. Hence, that's the reason why it's faster. There are less problems and more throughput because I'm not dropping packets and retransmitting like crazy. Okay, so I/O graph is a very useful way of determining whether the bars at the bottom are causing you grief. Okay, again, disclaimer, these are not all error events. Keep alives, Windows updates, they're all considered TCP.flags. Okay, but there is something here that you can add to see additional things for anything that's throughput related. And this is something that was added because I'm not taking credit for it. Kerry, who's here, I believe he has a session, added this into Wireshark because I always do this when I'm troubleshooting, and that's from push bit to push bit, how much data did the application send, okay? Because when you set a push bit, you're flushing the buffer, and so this is a way of application saying, I'll give you this much data to transfer TCP, and when you're done with that, I'll give you the next chunk of data, right? It's a very common way from a network perspective of determining who's controlling the flow. So who's doing the flow control? There's a TCP flow control with window sizing and congestion algorithm. We know about that. But there's also application level. I'll give you this much. I'll give you this much. I'll give you this much. And the problem with I'll give you this much is if they don't give you enough, you pay a round-trip penalty for every time the application says, I'll give you this much. Okay? And the good way to find out is you can actually do push to push. And you can say TCP.analysis. And in here is TCP.analysis. Flag. Wait. There it is. You can see here flags. Where is it? It's push bytes. Okay. So push byte sent, and I'll change that color to red. Is say okay. So now the red is push to push. How much chunk of data is this application willing to send to me? And the bigger the red, because I changed it to TCP analysis that push byte, push flag, whatever that display filter was, that gives me the amount of amount of data the application is willing to give to TCP to transfer. Okay? Does that make sense? A good way to think about this is TCP has a 747 ready to transfer passengers to Charles de Gaulle Airport. But if the application gives you 10 passengers at a time, that 747 has to load up 10 passengers, fly to Charles de Gaulle, CDG, and back. And then the application gives you the next 10 passengers. That's the push-to-push byte size, how much data. So you can imagine if you have 1,000 people to transfer, you can do it in 2 round trips if you fill up the 747. But if they give it to you at 10 people at a time, it's going to take a couple hundred round trips. Okay, so that's a good way of indicating and determining how efficient the application is. Okay, before this TCP analysis that push to byte, I would have to export the Wireshark. I'll show you how to do that. And I would export this into Excel, and then I would look for the push bit, because as we know, every TCP packet has push bit set. And I would go from looking at this, look for the push to push and how much data, cumulative bytes, it sent. Very manual way of doing it. It was kind of annoying. And then, and when you do sequence number analysis, this is the metadata that Kerry added to Wireshark to help you determine how much byte is outstanding from push to push. How big is the bucket size the application is willing to give to TCP? Okay? So the number one indicator of a chatty application is how many push bits you see in a trace file. And a very good way to see that is to add this as a column, because if I come down here, somewhere down here, I'll just pick, I don't know, somewhere here, we can see that since the last push bit, I had 58,000 bytes. Not a bad thing, right? That means the number of passengers that the application gave me up to this point is over 58,000 passengers that TCP now has to send across without waiting for a delay. Okay? When you're troubleshooting application, you have to understand this number, push flag, okay, to push, right? Bytes since last push, and bytes in flight. How many bytes in flight is also incredibly useful indicator. I went into this in detail last year. So if you go to my YouTube page and look up the SharkFest session from 2018, I actually drew a diagram of packets in flight and whatnot, and why it's so important to understand bytes in flight and also bytes since push flag. Okay? And you're thinking, wait a minute, you just said bytes in flight and push flag are related. How can this be 1460 and 58,000? How could that be? How can they be off by, that orders of magnitude? It's because where you're capturing, you're either the sender or the receiver. And if you're the receiver and sender, the bytes in flight can be small, but the receive could be heavy, and vice versa. Okay? So when you're doing TCP analysis, you have to always remember it's a bidirectional transfer, and you need to keep that straight. That make sense? I think I might have went through that too fast, because it just dawned on me that a lot of you, this is your first SharkFest, and even though I went over this ad nauseum last session, you may be thinking, what the hell is he talking about? If you watch the session from last year, it's not that long, I go into this part in detail, but trust me, bytes since last push flag and bytes in flight are critical to determining if the application is at fault or not. Okay? Now, let me show you another trace file. And it's going to be a teaser. And the reason why it's a teaser is because I decided to get back onto YouTube of packet analysis. And so my goal this year is to produce maybe every 2 weeks a short 10-minute, 15-minute video on how I do analysis, from the very beginning, very basic, to the most advanced. And my inspiration was, believe it or not, a carpenter from New Zealand who woodworking, right? I watch carpentry videos. It's fascinating to me. If anybody here into woodworking or carpentry or anything like that? No? Nobody? All right. You're missing out. But here's a guy in New Zealand that started a YouTube channel with 10 people, and now he has, I think, 600,000 or something like that, and nothing else. People, DeWalt, Makita, and of the world, they keep sending him free stuff. So I figured, you know what? If I can get my subscriber to over 5,000, I think I have 4,000, 5,000, something like that, then they'll send me free stuff. No, I'm just kidding. I'm doing this because I don't code anymore, except for Lua for my flight simulator. And it's a way of giving back to the Wireshark community. Okay, so I'm using this as a teaser because it's publicly being shamed if I don't follow through. And this New Zealand carpenter, over a year, went to 70, 100,000, 600,000 subscribers, and it's very, very useful content. And I believe that if I start from the very basics and do this, a lot of you will benefit, especially if you're new to packet analysis. Okay, so I'll do that. So, what's the trailer? What's the sneak peek here? Because we only have 10 minutes. This is a real-world problem that I diagnosed and solved, more or less. And the way I did it was I did this, and I thought, oh, there's a pattern here. You see the pattern? Anybody see the pattern? Believe it or not, there is a pattern here. And I did it by doing this. As I scroll down, And I know when I first do this, people think, you're full of crap, you can't do that. You can, trust me, you can. And the pattern that I picked up is that bracket that shows up in chunks, in groups of 2, every couple of pages. There it is right there. And I'm looking at this, and this, and this, okay? So I'm going to go back to the top, and I'm going to scroll down again. There's one right there, there's another one, 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 there's another one. Every page has it, okay? I get excited when I see a pattern, because if there's a pattern, someone's doing it. Network issues are completely random. Packet loss are completely random. When you see a pattern, you have a pretty good chance of figuring out what the hell is wrong, okay? So, this could be an entire SharkFest presentation, and it is, but I'm not going to do it for you because I'm going to break this up into 5 to 10 parts of YouTube video. So if you're interested in packet analysis, keep an eye out because I'll start uploading this one where I break it down, and then I'll go back to the very basics. So my promise is that you'll see 2 or 3 or 4 or 5 videos in the next couple of months that talk about this specifically, and it has to do with the retransmission timeout. It has to do with spurious retransmission. What the hell is that? And why am I acknowledging something that I've already seen, and whatnot. So it's a fascinating use case. Okay? All right, so I hope normally, all I do is do packets, but the first 30 minutes of this session was I didn't even open up Wireshark because it was troubleshooting storytelling. I hope you found it interesting, and I did some packet analysis here, and then followed by this would be my promise to you to follow up on that, okay? So with that in mind, I'm going to stop the video because this session I don't want to